Hello, we are a senior capstone team for the IMSE department at Iowa State University, and today we're presenting line labor optimization and ergonomic tool design for our capstone project. Our team consists of Joe Badalucco, Beth Clow, Ellie Larson, and Kelly Ryan. Some background about our project is that we worked on a harvester sandwich assembly line, which was experiencing high cycle times, non-value added movements, and potential ergonomic risks to the line. Our project objectives included reducing labor costs by 20%, reducing production time by 10%, and introducing a safety initiative to the line. Listed below are some of our assumptions and constraints for the project.
For the current state analysis of our project, we conducted time studies for the slider and harvester sandwiches. We observed throughout our time studies that there is minimal whip building up along the line, and it only occurred at the transfer table. The PFM uptime was approximately 60%, and due to this variation, it was the bottleneck of the system. The packout station was the only station meeting the desired cycle time, and there's approximately $18,580 a year of additional labor due to the line currently running one stream of meat. Additionally, for our current state analysis, using the stamping tool required 33 plus or minus 2 pounds of force to cut through the slider sandwiches. Because of that reason, our team conducted a Rogers fatigue analysis and observed that there were over 15 stamps a minute using the tool. The wrist angle extension was greater than 45 degrees, and there were pinch grips on the tool of approximately 0.25 inches in diameter. The methodology that our team used moving forward with the new tool is improving the grip, implementing taller non-serrated blades, and implementing a mechanism to keep the bread in place so it can become a two-handed neutral grip tool. From our observations, the key conclusions that our team observed for this project is that running double streams of meat would be cheaper than running single streams of meat. The bottleneck is due to the PFM variation, and a new stamping tool is required for ergonomic improvement.
All right, now we have the future state design, specifically the line layout. The key thing to note about the line layout is that the weigh station was moved to the front to reduce the non-value added time. We did this because we found operators rushing a lot at the weigh station's old position. We also allowed for stricter tolerance over meat ingredients, and if capacity allows, to run 2 streams of deli, and also to reduce variable labor time on the line by 50%. All right, the next part of the future state design was the PFM standard work. This was incredibly important for reducing variability and helping new operators. These steps have sequence of 1 through 10, and it helps make a standard procedure for setup and teardown.
All right, so for redesigning the tool in the future state, this is a model of it put up in SolidWorks. In red indicated the bread press mechanism, because the original problem with the sliders is that the tops would fall apart as they pulled their blades out through the sandwich, so this would keep contact with the sandwich throughout the cut without them having to use their other hands to do it. This would help reduce forces applied by 50%, as it is now a two-handed operation, and create a neutral power grip compared to what they were doing before. And lastly, in order to keep this tool lightweight, as they'd be using this for a significant amount of time on the line, be made of UHMW and 304 stainless steel. So the last little bit of this and wrapping it up with our final summary and ROI. We say reduce labor costs by 22.9% by implementing the double streams of deli on the line and moving the weigh station to the front. By implementing these stricter meat tolerances for the ingredients, you see a mean weight of the sandwiches moving 3.34% closer to the ideal weight, which would be indicating the ingredient savings per year to the right. The estimated cost of a strain per OSHA regulations is indicating our safety savings per year at $32,000. And lastly, costing based off of the Midwest retailer supplier quote was about $3,000 for 3 of those tools. Expect a payback period of less than 5 days, and given a 3-year NPV and discount rate of 10%, they'll see a little under $560,000 in savings.